Turning the knob over to ohms, we have the ohms settings. We hit select until we see the volts, and this is where we find the diode checker, which is the little diode sign. Now the diode checker is a very handy thing for test. For example, here is a diode. The diode has an anode and a cathode. The cathode's marked with a band. If we test across with the black lead on the cathode and the positive lead on the anode, the tester will tell us what the forward voltage drop of that diode is. That's the voltage drop it'll have even at no load if you forward bias it. So this particular diode is going to drop 0.57 volts to make it turn on, and it'll have additional voltage drop depending on the load. If we swap the leads and put the positive on the cathode and the onto the anode, it reads overload, infinite resistance, which is a really good thing. That means that the diode is not shorted out. Very good thing to test. So another good thing to test with this, that's another type of diode, is an LED. And it's the same thing. An LED is a diode, it just gives off light. So for this one in particular, this is a higher power LED. We'll put the cathode onto the negative side and the positive on with that lead. And what's amazing, so you can see the LED lights. The meter is showing overload still. That doesn't mean that the LED is broken. It just means that the forward voltage drop is greater than 3 volts. That's all these meters can about do for that. But it's around 3 volts because you can see the light is lit, so the LED is working. So if I take that off and just swap them, put the cathode on the plus and the plus lead on the minus, it reads open circuit and you don't see the light turn on. So the LED is good. It tested the LED. It's just in this case the forward drop on this big diode LED is so great that it's greater than 3 volts, so it's not registered on a meter. And that's pretty normal. And for regular LEDs, the cathode can be told a couple different ways. If you look here on the LED, there's a flat spot. And that is on this pin here. You can feel it right on the edge of the LED. There's a little flat spot. That's the cathode side. Also, if you look at the leads, the longer lead is the anode. So what we're going to do is we're going to test this green LED just to see what its forward voltage drop. And you can see that it just turned on slightly. And its voltage drop, its forward voltage drop is 1.82 volts. And so we'll use that when we calculate the resistor that we would like to use with it for driving it. And we'll go over that later on whenever we go to measure the milliamps going through that LED. And what's interesting, the different color LEDs all have different voltage drops. So we'll try this yellow one. This one is 1.76. And you can see, yes, the LED lit up. I can make that up here. So it lit up whenever we applied that. I'm not sure if you can see that very well. So we know this LED is good. And we can try a red one. And I've got the lead wrong. So we'll swap that. And you can see the red one lit ever so slightly, and it's another 1.83 volts drop. These are the same type of resistor. And here's a LED, and here is another one Here's the cathode side. And this one is also a red one, and it's 1.63. So this is kind of handy to have if you're trimming up all your LEDs to make sure that they're all pulling the same load. Especially some of them have a very small voltage drop, and some of them have a pretty large one, like the blue LEDs. And then here's a green one. Yeah, that one is an ultra bright. You can see how it lit up like the sky, but you can't see its voltage drop because it's still kind of high. So it's greater than 3 volts.